All right, section 2.3 for Algebra 2, we're going to start looking at linear equations. We have multiple types of linear equations that we can write, different forms. We're going to start looking at the first one today. So we're going to be graphing some lines. We're also going to be writing them, equations for them in slope-intercept form. Okay, that's one of our few forms that we have. All right, so what is slope? When I ask about slope, what comes to mind? Okay, we've learned it as rise over run. Other ideas? So y equals mx plus b we're going to get to. That's one of our equations for a line. But in that equation, what's the slope? She said y equals mx plus b. Which one in there is the slope? The m, yep. So we usually use an m to represent slope. Any other ways of thinking about slope? What does it mean when we say rise? What are we looking at? The change in y over, what's run then? Okay, so change in y over change in x. Have you seen this symbol before? Delta y over delta x. Okay, another way of saying that. Change in y over change in x. Okay, so we have different types of slopes. For a positive slope, what would it look like? So draw it with your fingers. Okay, so we're starting low and going up high. So just like we read across a page, as we read from left to right, our line should be going up. Yes? Okay, negative slope, our line is going down. All right. What would a line that has a zero slope look like? I see some hands. Horizontal? Zero slope? Okay, so when we say something has a zero slope, we're saying rise over run has to equal 0, right? For that to work, the rise would be 0 and the run could be anything, right? We can take 0 divided by anything and we get 0. So in this case, are we rising 0 to go from one point to the next? Are we moving up 0? Yes. We're still running a distance. But again, the run can be anything. If we have 0 divided by any kind of run, we're going to get a 0. Okay? How about undefined? That's a vertical line. Try to make it look vertical here. So in this case, when we talk about rise over run, if we want it to be undefined, now we're talking about having a run that's 0, right? We can't divide by 0. So any kind of rise divided by 0 is going to be undefined. Okay? And in this case, we can rise, but we're not moving left or right at all. Questions about that? Okay. So when we talk about a slope and we're talking about that rise and run idea, we can take any 2 points on our graph, right, and think of a triangle. How much do we rise? How much do we run? And we're always kind of moving left to right. So to go from this left point to the right point, how much do we rise? How much do we run? Okay. All right, so if we were going to calculate the slope, when I asked you guys to tell me about slope, nobody mentioned an equation. How do we find slope? Okay, so we talked about it as change in y over change in x, right? So we have to change our y coordinates, right? How much do those change? So we calculate slope by subtracting our y-coordinates and then dividing by the difference between the x-coordinates. Does it matter which one is y2 and which one is y1? It's kind of a trick question. It doesn't necessarily matter which one you pick as point 1 or 2, but what matters is that you pair them up the same. So if you're going to call this first one here point 1, then this would be y1, this would be x1, right? They go together. This would be y2 and x2. So it doesn't matter which point I pick as first point, second point, but if I pick that one as the first one, the x is x1 and the y is y1, right? Those have to match. Okay, so subtracting our change in y. Do you want to do 2 minus negative 5? Do you want to do negative 5 minus 2? Doesn't matter, but you have to set the x's up the same way, right? That's what I mean when I say it doesn't matter which point you call first point, second point. You're going to take your y-coordinates and subtract them, and then you're going to subtract your x's in the same order. Okay, so if we do negative 5 minus 2, then what do we have to put for our denominator? What's the order going to be? All right. So negative 5 minus 2 gives us what? All right, for our denominator, 4 minus a negative 10 becomes positive 14. We can reduce this to negative 1/2. Now, for this first one, I am going to show you what happens if we went the reverse direction to just prove that it doesn't matter. We did negative 5 minus 2. If I chose to do 2 minus negative 5, then I would have to do negative 10 minus 4. Numerator now becomes a positive 7 and denominator is the negative 14. But it still reduces to a negative 1/2. Yes? So on a line, if I go from here to here and I'm counting rise is positive, run is positive, it's the same thing as if I said I'm going to go down and back. 2 negatives is the same as 2 positives. Yes? When we're dividing. Okay, I'm going to pause the recording. I want you guys in your groups to do the next 2. Calculate the slope. You don't have to do it both directions. Just pick one direction and go. All right, let's check for question B here. Subtracting, notice our y's are both negative 1, so it doesn't really matter which one I subtract, right? Negative 1 minus negative 1, I'm going to do 5 minus 6. What do we get for a numerator? 0. Doesn't matter what's on the denominator, does it? What's my answer going to be? 0. Okay, for part C, when we subtract, if I do negative 3 minus 5, then I have to do negative 2 minus negative 2. What happens on this one? The denominator becomes 0. And anything divided by 0 is undefined. In this case, we have negative 8, but still going to be undefined. All right, questions on slope at all? All right. So when we talk about linear functions, we're just referencing an equation that's graph would be a line. Okay, so linear function is a function whose graph is a line. We can represent it with a linear equation. And at the beginning of class, I said we're going to look at different forms that we can use to write linear equations. A solution would be any ordered pair that makes that equation true. All right, so any point on your graph has to work in the equation for that line. So we've talked about the very beginning, slope-intercept form. That is one of our forms for writing an equation for a line. And what does slope-intercept form look like? Good. Y equals mx plus b. What is the m in this case? All right. And in this case, b is your y-intercept. What do we mean by a y-intercept? Where it hits the y-axis, right? Where your line intercepts the y-axis. Okay. So for the first one here, it says we're asked to write an equation for each line. In part A, I'm telling you that the slope is 6 and the y-intercept is 5. The line is going to go through the point 0.05. Okay, so what equation would we write? Yes, y equals 6x plus 5. Okay. For the second one, I didn't give you that information, but I gave you a graph. Can we figure out the same information from our graph? So let's look right here. This is where I'm crossing the y-axis. What's the value? Y would be -3. Okay, so in this case, my y-intercept or my b value is -3. Okay. Can we identify the slope? Is this slope going to fit in our positive, negative, 0, or undefined category? Which one? It's a negative slope. I ask that because you'd be amazed how many people will give me a positive slope answer even when looking at a negative slope line. Okay? So make sure that the equation you're getting makes sense with the picture you're seeing. So we are actually going down, right, and over. So if we count grid spaces, we are going down 2, and we're going to run 4. All right, so our slope would be -2/4 or -1/2 if we reduce it. So the equation for this line, y equals -1/2 x minus 3. Okay. All right. Example 3, show how you can rewrite each of the following in slope-intercept form. Once you get it rewritten, we're going to identify what the slope is and what the y-intercept is from our equation. Okay? So what do we have to do on this first one to turn it into y equals mx plus b? How can we rearrange it? We want to get y by itself. What do we have to do? Subtract the 3x and divide everything by 2. Notice I said divide everything by 2, right? So the slope gets divided by 2, the y-intercept piece gets divided by 2. So we can identify now our slope is -3/2 and our y-intercept is the 0.09. Okay? Questions about that? Any questions about why I wrote it as 0.9? I can say that b equals 9, right? In my equation, b equals 9, but where it's crossing the y-axis is the 0.09. Okay. How about the next one? It has fractions. Most people would prefer not to work with equations that have fractions in them. Is there a way we could get rid of the fractions? Well, we can work through it with the fractions still in. If you want to do it that way, we can. There is a way we can get rid of them. I'll talk about it in a minute. If I were going to do this just the way it is, leaving the fractions there, my first piece would be to add 3/4 x to the other side. Okay. Then what do I have to do? I have to divide out the -1/2, and that's equivalent to Multiplying by reciprocal, yes? So I'm going to multiply both sides by a -2. We end up with y equals -6/4, which reduces to -3/2, yes? -2 times 3/4, yes? -6/4 reduces to -3/2. Okay, so -3/2 x plus 2, if I distribute the -2 in. Okay, so that was one option. The other option, if you want to just get rid of all the fractions at the beginning, look at your denominators. If you were going to get everything to have a common denominator, what would you pick? What number? What's a number that 2 and 4 both go into? 4. I could times everything by 4. Okay, look what happens if I do that. If I times the whole thing by 4, okay, both sides. As long as I've times both sides by it, it's still equivalent, just going to look different. Multiplying this, I get -3x. Multiplying to here, 4 times -1/2 is -2. 4 times -1 is -4. And now it looks more like the first equation that we did, right? Where we can move things around. Doesn't matter to me which route you go, you're going to end up with the same answer. Okay? All right. This one says, rewrite each in slope-intercept form, identify the slope and the y-intercept. Sorry, I think I skipped that on the last question, didn't I? Identify slope and intercept. So for this last question, our slope was -3/2. And our y-intercept would be 0, 2. Okay. So I'm going to pause the recording. I want you guys to rewrite this in slope-intercept form. Identify the slope and the y-intercept. If you know how to graph it, go ahead. If you don't, you can wait for a minute and we'll talk about that. All right, what did you do first? Okay, subtracting the 3x makes it negative now on the other side. And then, okay, so dividing by -4, we've got a positive 3/4 x and a -6. Yes? Okay, so our slope is 3/4, which means we're going to rise 3, run 4. And our y-intercept, we're going to hit the y-axis at 0, -6. All right, so we start with our y-coordinate, our y-intercept, and we're going to rise 3, run 4 from there. Okay? Make sure you do that twice so you have 3 dots. Anybody would know why we have 3 dots? Why we always tell you 3 dots for a line? Okay, if I gave you 2 dots, if I gave you this point and this point, I could draw a line that hits like that. I could draw a line that hits like that, right? I'm getting different lines. If I have 3 points, I'm lining it up better. Yes? So we always want to see 3 points for that. All right, and then connect them. Check that you have arrows on the end. It is a line. It goes on forever. All right, last one. First step. Everybody, first step. Minus the 4x. And then divide everything by -7. So we end up with positive 4/7 x and a -2. So slope is 4/7, y-intercept 0, -2. So 0, -2 is there. We're going to rise 4 and run 7. Now, I'm kind of out of graph, right? To run 7 more. Can I go down 4 and left 7? If I reverse both directions, I'm still okay. So down 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7. Yes? And then draw a line. Any questions? What's the form we just talked about? Slope-intercept. All right. So there is your homework. I will be passing out some graph paper for future reference. If you need graph paper, there is a stack bin in the back corner there that you can grab some. Okay?